Hello students, welcome to Untitled College online classes. So in the last class we have discussed about the Vpd and in terms of energy consideration. Yeah. So another one concept here, orbital overlap concept of covalent bond. Clear? So orbital overlap concept we have discussed in this class. Clear? So according to this concept, the covalent bond is formed by the partial overlap of two off-field atomic orbitals containing electrons in opposite directions. Clear? So that is the concept here. Orbital overlap concept. What is the orbital overlap concept here? So here, partial overlap. How covalent bond is formed? According to this concept, the covalent bond is formed by the partial overlap of two off-field. Very important. Two off-field atomic orbitals containing electrons in opposite spin. First, you write the sentence, then, and I will take one example. You can easily understand. Clear? Right here. So here, according to this concept, covalent bond is formed. Covalent bond is formed by partial. This is important. Partial overlapping. Of two half-filled, very important this is, two half-filled atomic orbitals, two half-filled atomic orbitals, two half-filled atomic orbitals containing electrons in opposite direction, in opposite direction. Clear? This is clear. So the covalent bond is formed by the partial overlapping. Important, this is partial overlapping. Clear? Of two off-field atomic orbital containing electrons with opposite direction. Means the containing electron and those direction of electrons should be opposite. Clear? So what is this partial overlapping? Partial overlapping means, clear? So a partial overlapping means a part of electron cloud of two off-field atomic orbital becomes common. Clear? So just I will take one example. Clear? And what is that example here? Formation of H2 molecule. Clear? No? Formation of which molecule? H2 molecule. First I will write here formation of. Then we can easily understand what is this concept actually. Formation of hydrogen molecule. How this hydrogen molecule? Hydrogen molecule means what it means? There will be a covalent bond, one covalent bond between the hydrogen and the hydrogen that has to form. Clear? You know hydrogen. Hydrogen means what is the electronic configuration? Hydrogen means how many electrons it is having? One electron, so that's why 1s1. So this is the orbital, 1s orbital, atomic orbital. Atom, this is atom orbital we will call as atomic orbital. These orbitals involved in the overlapping. Clear? So this is one hydrogen, another hydrogen, you know what it is, 1s1 atomic orbital. Clear? These atomic orbital partial overlapping takes place. Off-field atomic orbital, because here also orbital is having what? Off-field, because in 1s orbital, 1s means you know this is in one orbital how many electrons can be filled? 2, but here only one electron is there. Off-field it is. Here also what it is? Half-field. This is also one electron. Clear? Now I will write this is. This is clear? This is hydrogen. One means this is 1s orbital. 1s orbital of one hydrogen plus another one, what it is? 1s orbital of another hydrogen having spins are what it is? Electrons are in opposite direction. Clear? So clearly I will write, then we can clear that. Yeah. So just what I will say. This is 1s orbital. Clear? So now I will write this is 1s orbital. This is 1 orbital. So 1s orbital of 1 hydrogen plus another 1s orbital of another hydrogen. So that electrons must be in what is opposite direction, and then their overlap takes place. Clear? So which orbitals overlap takes place? Always off-field atomic orbital. These atomic orbitals means which orbital? Valence shell only. Valence shell electrons only they involved participate in the overlap. Clear? So 1s orbital, and this is also 1s orbital. 1s orbital of 1 hydrogen, and this is 1 hydrogen, this is 1 hydrogen. Or simply you can write hydrogen here and here. 2 hydrogen atoms. They combine, they overlap. Which overlap here? Partial overlap. Means this is clear? Partial overlap. Clear here? This is partial overlap. And now, and 2 electrons are present here in this region, overlapping region. Clear? So this is clear? Yeah, 2 electrons with what it is one? Opposite spin. Clear? So this is 1 hydrogen and this is another hydrogen. So here what is there? 2 electrons are there. Then simply what we can write? We can write here H and H. So this is we will call partial overlapping. Partial overlapping means what is it? So here the part of electron cloud, the part of what is here electron cloud. Here orbital means what is it? Orbitals are filled with the electrons. Clear? So electrons means they are present not in exact position. They are in which they are present in any of that space. That we will call as a probability of finding electron. Clear? So they have studied already in the atomic structure. So here and this part of this is and part of electron cloud is common for the 2 off-field atomic orbital, and this we will call as a partial overlapping 2 off-field atomic orbital containing electron in which direction? Opposite direction. If you write in the same way electron cloud, you see this is electron cloud means S orbital. How this S orbital means? This is 1s orbital. 1s orbital. These are what is one? Electron cloud. This is electron cloud plus another one is what it is one. This is another 1s orbital. This is nucleus, and this is what is here electron cloud. Then what will happen here? They combine. Partial overlapping. Clear? So here this is nucleus. This is what it is. Electron cloud. So here there will be a electron cloud. So this is what hydrogen, and another one is here hydrogen. So what we will get? H2 molecule. Now you see, very important. This is the region of overlap. This is what it is here. Region of overlap. Clear? In this region of overlap, the probability of the finding electron is more compared to the other spaces. Clear? So in this region, the finding of electron is, the probability of finding electron is more compared to the other spaces. Here also electrons are there. Here also these electrons will move here and there. But here, probability of finding electron means these electrons are present maximum time in the region of overlap. So that's why they are present at maximum time in the region of overlap, and they are simultaneously attracted by 2 nucleus and forms here 1 covalent bond. Clear? So this is the formation of which molecule here? H2 molecule. Which orbital involved in the overlap? Half-filled atomic orbital of valence shell. Clear? This is best example. Clear? So next one. In the same way, I will write here formation of H2 molecule. I have mentioned here. I will write formation of HF molecule. Formation of which molecule? HF molecule. How they form? According to the overlap. Here orbital overlap concept of Vpd theory. Clear? So now hydrogen means you already know one electron will be there. Fluorine, what is the valence shell electronic configuration? 2s2 and 2p5, isn't it, man? So here 2 electrons are there in the s orbital, and here how many electrons? 1, 2, 3, 4, 5. Here 2s, and this is 2px, and here 2py, and here 2pz. In the 2px, how many electrons are there? 2. 2py, how many electrons are there? 2. And 2pz, 1 electron will be there. Which orbital overlap with the 1s orbital? These all 2s orbital, 2px and 2py, these all are fully filled orbitals. This is 2pz is a off-filled orbitals only participated in the what is overlapping off-filled atomic orbitals only. These are atomic orbitals. Off-filled atomic orbitals only participate in the overlapping. So that's why what happened, you see. This is 1s orbital. How the overlap takes place here? 1s orbital, clear? So this is 1 electron. This is what it is, 1s orbital. This is 1s orbital of which one? Hydrogen and plus. Clear? So I will write it down here. Clear? 1s orbital. This is 1s orbital, 1 electron. Nucleus is there here, 1 electron, and here 1s orbital. 1s orbital of which one? Hydrogen. Of hydrogen plus, and here and 2px and 2pz and 2py are there. I will write p orbitals, all I will write here only. This is 2pz, this is 2pz, I will write 2pz this, and this is 2px, or this is what it is, 2py. Clear? So just assume this is z axis. Clear? So this is z axis. This is, I will write, this is z axis like this. Clear? So this is what it is here, 2pz. Just assume this is a 2py. This is 2py. Then what should be? This is what? This is a 2px. This is what it is here, 2px. But here in the 2px and 2py, how many electrons are there here? 2 electrons. And here also how many electrons are there? 2 electrons. But here how many electrons are there? 1 electron. Where? In 2pz. So here this is p orbitals. Clear here? So this is p orbital of fluorine. Clear here? So this is p orbital. P orbitals of which one? Fluorine. Then what will happen? These two, because here 1s orbital having 1 unpaired electron and a 2pz orbital having 1 unpaired electron. So that's why unpaired off filled. These are means what we can say. Off filled. 2 electrons are fully filled. Off filled atomic orbital, they are partial overlapping takes place. They overlap here in this way. So how they overlap means, so I will write like this. So this is clear? So you know that this is what it is, 2pz, and here this is a 2py, and this is a 2px. They are here, 2 electrons are present here, but in this one electron is there, 1s orbital. Clear? So here how many electrons are there? 2 electrons with opposite spin, and this molecule we will call as what is here, HF. Due to this overlapping, 1 covalent bond is formed, and this we will call as a HF. Clear? So this is what it is here, formation of HF molecule. Another one I will write here, formation of F2 molecules. Clear? See, this is overlapping concept. Have you understood or not? What is the overlapping concept here? So overlapping concept and partial overlapping takes place between the 2 off-filled atomic orbitals containing electrons in opposite spin or opposite directions. Clear? So next one. Next one is formation of which one here? F2 molecules. Formation of F2 molecules. Same here also. F2 means one it is one. I already mentioned 1 fluorine is having 2 electrons here and 2, 3 electrons means 5 electrons in. So here 2s here and this is 2p. 2p means what? 2px2, 2py2 and 2pz1. And another fluorine also you can write here in the same way, same atomic configuration. This is clear. So here 1, 2, 3, 4 and 5. In this one 2pz is having 2pz is having 1 unpaired electron, and here 2pz is having 1 unpaired electron. These will not participate in the overlapping because they are fully filled. 2 electrons are there, which here we see these are fully filled orbital. This is off filled orbital. So that's why in one orbital how many electrons can be filled? 2. If 2 electrons are filled, that orbital will be atomic orbital we will call as a fully filled atomic orbital. If 1 electron is filled, off filled. So here same I will write, and the same previous what I have written. This is clear. So Z orbital, and this is X, and another one is Y. Clear? So this is which orbital here? 2pz. This is X. Clear? So this is what it is, 2py, and this is I have taken 2px. You know all these are 90-degree angle to each other. Clear? So this is in this one. So we have 2 electrons. In this one 2 electrons. In the 2pz how many electrons? 1 electron only. Next one. Same I will write another one here. Clear? So here this is what it is. This is a 2pz, and this is 2py. 2py, and this is what it is 2px orbital. So these are 2px orbital. But in this one there is another electron. It can be with the opposite directions. Then what will happen? These two overlap and form a what is bond here. You will get a here covalent bond between these two electrons combined and overlapping. That is dimension. Clear? So then you will get the resultant here. Clear? So now here there are other orbitals are present. Clear? Here also other orbital 2px and 2py orbitals also present. In this one there will be a 2 electrons, and here this is a y. These are which orbitals? Y orbital. This is z orbital. Clear? So this is x orbital. Clear? Here also this is x orbital. Clear? So this is z orbitals. Clear? So now what happened? You see here in this one there are 2 electrons. Here there are 2 electrons. Here also there are 2 electrons. Here also there are 2 electrons. 2py, and this is what is 2px, and it is also 2py, and it is also what is 2px. Then what will happen? This is one fluorine. This is one fluorine. This is another fluorine. Clear? This is one fluorine atom. This is another fluorine atom. If you want, you can write here. This is one fluorine. This is another fluorine. They are forming. So this is due to partial overlapping. Then bond formation takes place. You will get the F and F bond. Clear? So this is about the what is here orbital overlap concept of formation of covalent bond. So next one is non-formation of H3 and H4. And when you see the first video when we discussed about the chemical bonding, I have mentioned there some questions we have arised. Why do atoms combine? That I have already given. They combine. I have given already reason for that one. Which is a theory has given reason for why do atoms combine? That Lewis and Poisson, because to attain the octet. And second one, some combination, certain combinations are only possible, not all. H2 can form, but H3 and H4 cannot form. So that not explained by and Lewis and Poisson theory, but it is very clearly explained by the Vpd by using here orbital overlap concept. Clear? So what is that one? You know that just now only we have discussed the formation of H2 molecule. One atom, this is one hydrogen atom, this is what is one hydrogen atom, and another hydrogen atom, they are with opposite spin. This is hydrogen atom. They overlap each other and partial overlapping takes place, and it forms what it is? Hydrogen and hydrogen means hydrogen bond. Clear? Why they form? Because they have one unpaired electron, two involved in the overlapping to form a covalent bond. But if you take H3 molecule, H3 molecule to exist, you know, like H3 means there should be a H and there should be a H, like that. One is the central atom, you know, one we have to write the central atom, around that we have to attach, we have to put the surrounding atoms, like that. Then we have to write Lewis structure, like, isn't it? So Lewis got structure. So means this hydrogen has to form how many bonds with the surrounding atoms? 2 bonds. But you know, in this case, hydrogen atom, one hydrogen has only one unpaired electron. It is having only one unpaired electron. That one off filled, one electron means what is not? It is having only one off-filled atomic orbital. So that one off-filled atomic orbital can overlap with the another one off-filled atomic orbital of another hydrogen. So these two can form. But to form another bond, this hydrogen is having only one off-filled atomic orbital, so it can form only one hydrogen. No more off-filled atomic orbitals are available with the hydrogen, so no more bonds can form. So that's why it can form only what is one bond. So it cannot form what is H3 or H4. That is why some combinations are possible means that is explained by the Vpd theory. Why not? Because this hydrogen having only one unpaired atomic, one off-filled atomic orbital, so it can overlap with the another hydrogen off-filled atomic orbital to form a HH bond. No more half-filled atomic orbitals are available in this hydrogen to form another bond. So this molecule cannot exist. And also we have discussed a non-formation of what is known here, non-formation of H2 molecule, He2, helium molecule. Non-formation of helium molecule. That also can be explained by using this one here. Overlap, that means orbital overlap concept. You know that helium, what is that one? 1s2. 1s2 means what it is, man? This is 1s orbital. Here, how many electrons are there here? 2 electrons are there. Means it is a helium is having fully filled atomic orbitals. Clear? Another helium if I take. This is also what is 1s2. Here also how many electrons are there in the 1s orbital? 2 electrons are there. You know, these are helium is having, you know, and fully filled atomic orbital, so it cannot overlap with the another 1s orbital of the helium. Why it cannot overlap? Because overlap means only off-filled atomic orbital involved can overlap, or only what is half-filled atomic orbital can overlap with the another off-filled atomic orbitals. Clear? So here what it is? These are fully filled. This is what it is, fully filled 1s atomic orbital, 1s atomic orbital, 1s orbital. So that's why overlap means this helium and another helium orbital means fully filled orbital cannot overlap to form a He2 molecule. So that's why you know that only in the overlapping, which orbital will overlap takes place? Half-filled atomic orbital only involved in the partial overlapping. But in case of helium, there is no half-filled atomic orbitals. Here only fully filled atomic orbitals. So no case of what is overlap. So that He2 molecule cannot be existed. And this is what is my concept is given by what is known here. What it is, Vpd theory. And another one put the heading directional properties of covalent bonds. Next one, what it is, directional properties of covalent bond. Directional properties of which one here? covalent bond. Yeah. So what is meant by directional properties of covalent bond? Means the covalent bond is formed in which direction. So in which direction it forms and which shape molecule will get. So why? Because simple example I will say CH4 we have discussed, and CH4 the angle, the shape of the molecule is tetrahedral, means how the tetrahedral formation takes place. And you know, and bond means hydrogen atoms. Suppose carbon is there, hydrogen atoms are coming in this direction. In this direction they are coming to the central atom. They are, hydrogen is coming in this four directions. So that molecule is having which one? Tetrahedral shape. And why the bond angle is here 109.28 minutes or 109.5 degrees. Why ammonia is a pyramidal shape? Clear? And that will be explained by what it is here, Vpd theory. Vpd theory explained for polyatomic molecule geometrical shapes. Like what is the polyatomic molecules? Like you know, CH4, NH3 and H2O in terms of overlap and hybridization of atomic orbitals. Very, very important. Write that point here. Clear? So what is the point in this case? Right here. In case of polyatomic molecules, clear? Write that point. In case of polyatomic molecules, like what it is here, like what it is CH4 and H3 and what, and H3, H2O, etc. Clear? In case of polyatomic molecule like CH4, NH3 and H2O, the geometry of these molecules can be explained in terms of overlap and hybridization of, see one term has come here, Newton, hybridization of atomic orbitals. Hybridization of what it is here? Atomic orbitals. Clear? So means here directional properties of the covalent bond means mainly for in case of polyatomic molecules, the geometry of these molecules. For geometry of, to explain the geometry of this molecule. Clear? And here, and you know, the scientist Pauli mainly developed this one. So he explained the geometry of these molecules by taking the concept of what is overlap, and another one is what it is here, hybridization. This is important. Next we will discuss what is here, hybridization. And first of all, overlap of atomic orbitals we will discuss. And the failure is there. What is the failure of Vpd theory? Means means overlapping concept. I mentioned orbital overlap concept. It is not exactly correct. What is the failure in this one? And we will discuss. And after them, they introduce the hybridization to explain these properties, means geometrical properties are, you know, directional properties of polyatomic molecules, and this hybridization concept has been introduced, and that I will discuss. First, right here, overlap of atomic orbitals. Overlapping of atomic orbitals. Clear? Right. Overlapping of, put the heading, overlapping of atomic particles. Overlapping of atomic particles. So first of all, we have to discuss what is the overlapping of atomic particles. How many types are there? Yeah. So you know that I just mentioned hydrogen molecule formation. When one hydrogen and another hydrogen, they are when coming close to each other, overlapping of atomic orbitals takes place to form a H2 molecule. This overlapping of atomic orbitals can be positive overlapping, negative overlapping, or sometimes zero overlapping based upon the overlap. Nature of what is here? Overlap. And now, what are those we will discuss here? Clear now? So, overlap may be positive, negative, or zero depending upon properties of overlapping of atomic orbitals. Overlap may be positive, negative, or zero. Positive, negative, or zero based upon property of nature of overlapping, or simply you can write here property of overlapping of atomic orbitals. This is means the overlapping, one orbital and one orbital, they are overlap. That overlap can be a positive overlap, or that overlap can be a negative overlap, and sometimes we can observe zero overlapping also. Clear? So which are overlapping we will call positive, which overlapping we will call negative, and which overlapping are zero overlapping means that overlapping will not take place. Zero overlapping means that type of overlapping will not considered or will not take place. Clear? And that we will discuss here. And one concept here, generally we will take the z-axis as a internuclear axis. Clear? What is meant by internuclear axis? This is one imaginary line which connects the two nuclei. Which connects the two nuclei of the atoms. Clear here? So that is very important. Mainly generally we will consider the z-axis. So no, you don't think that only we have to consider the z-axis as a internuclear axis. No, not like that. Generally we will consider z-axis as a internuclear axis. What is the internuclear axis? It is a just imaginary line which connects the centers or nuclei of the two atoms. Clear? So that is z-axis. The right that one also. Z-axis generally considered as internuclear axis. Clear? So this is now what is the overlapping, positive overlapping, negative overlapping, that we will discuss. Clear? So right, first one is positive overlapping. Clear? So first overlapping, what it is here? Positive overlapping. What is positive overlapping? Clear? So positive overlapping means now, and you see here there will be a, suppose this is S orbital, and here another one is there is a PZ orbital. There is a which orbital here? PZ orbital. And that overlapping means how I will write here? Directly I will write here overlapping. This is S orbital and this is one P orbital. This is clear. This is positive charge and this is positive and this is negative. Positive. What is meant by positive? Positive means don't think that here cation or negative means anion. Clear? What is this positive means? Phase of wave of atomic orbitals. Clear? What it is here? Phase of wave of atomic orbitals. Atomic orbitals you might have studied in the atomic structure. While we are writing the atomic orbital, one we will write the positive and another one we will write the negative. Positive wave and negative wave means if it is a Z is a internuclear axis and this is wave. Clear? This is positive, this is negative. This is positive, this is negative. Clear, my dears? That is a phase of wave of atomic carbon. Clear, my dears? So that is positive and positive. Positive and positive. This is z-axis. This overlapping takes place along with which one? Z-axis. Positive, positive. Then it is a positive overlapping. And not only yes, this is S and P orbital. Clear? And here, in case sometimes you can write both are which one? P orbital. You can write both are which one? P orbital. One is P orbital and another one is, this is what is one? P orbital. S orbital. This is which orbital? P orbital. P which orbital? P z orbital. Why? Because it is a orbital R along the z axis. So that's why z orbital. S and Pz. Why? Because S is a spherically symmetrical and Z is a, Pz is a, and lobes are along the z axis. So overlapping should be takes place along which one? Z axis. So that is. So that's why another one is P and P orbital along with z axis. Along with z axis means it should be a Pz orbital. It is also should be a Pz orbital. This is negative, this is negative, this is positive and this is positive. Positive, positive overlapping. That is positive overlapping. Clear? And next one. Another one is, this is Px and another one is this is same atoms. Clear? This is also what it is now? Overlapping. Where overlapping? This is overlapping. This is overlapping. This is which orbital? This is z axis. Clear? It should be a 90 angle means it should be a px or py because px or py orbital making a 90-degree angle with the z axis. Perpendicular means what is 90 degrees. So this is, I will write this is orbital overlapping. One is px and another also should be what is px only. So here it is a positive lobes, both are negative. So positive overlapping. Here also negative means what? Positive only means same sign overlapping means that is a positive. Positive. Negative also what it is? Same lobes, same phase overlapping is a positive overlapping. In the same way, if I consider another one. Clear? So this is px. Just assume px. Py means this is py. This is py. Another orbital. This is also what it is now. Right here, py. This is z axis and clear now. This is both should be connected at this one. Clear? So this is positive, negative. So both are which one? This is also py orbital. This is also what is py orbital. Overlapping. Clear? So because py only they are in same plane. Py means what is this is py, same plane, so they can overlap each other. Clear? This we will call as a positive overlap. Can I write here negative overlap? Negative overlap means exactly opposite to this. Negative overlapping. This is another one is negative overlapping. Negative overlapping means what? Overlapping takes place in opposite phases. Means one is plus means another one is what? Negative. So this is only same I will write. This is clear? This is positive. This is negative. This is positive. This is z axis. Clear? Positive and negative overlapping. So it is a negative overlapping. Here also same. Clear? So here what it is? This is positive. It is positive means it is negative. It is negative means it is positive. That is, if one orbital, if I write this is positive, this is negative. One is above the wave means above the nuclear axis. Another one is the orbital is below the nuclear axis. Clear? So this is what is the axis. This can be what it is one. Negative and negative. Clear? Next one. And then z orbital is there. And this is one p orbital. This is plus and this is what is minus. If I write another one. Clear? This is minus. Now, if I write minus x, this is what is plus. This is what overlapping. This is negative overlapping. Clear? In the same way, if I write for this px and this is what is known here Px and Py, and this is what is known S and Pz. This is Pz and Pz, Px and Px, and now you have to write here. This is positive means this is negative. This is clear? Right clear? This is clear. Suppose it is a positive, it is a negative. It is a negative, this is a positive. This is which axis? Z axis, and this is a, if it Px, I'm sorry, Px this is, and this is Py, and this is what is known Py. It is negative overlap. That is clear. Last one is there. What is the last one here? Zero overlapping. What is that one? Zero overlapping. If you take here zero overlapping, this is the zero overlapping. Clear? So Z axis I will take, and suppose if there is a Px, this is what you know Px, and this is clear? Suppose it is Px, and this is which S. Is there any overlapping here? There is no chance of overlapping here. So here it is just connecting, touching. That's only. So it is what is not zero overlap. Zero overlapping. Clear what is Px? Or you can say Py also, it won't take, because, and next one, if I write here Px and Py, overlapping will take place, Px and Py. You know Px and Py orbitals are perpendicular to each other. Clear? And they will not, overlap. Why? To overlap each other, they should be in same direction. Clear? But here, in this one, if I take, this is a Px. If I take another Px, and these two are in the same way, so overlapping takes place here. But what I am saying here, one I am taking Px, and another one I am taking what is my Py. So that's why zero overlap. So here, if I take Px here, plus and minus, this is what is my Px. If I take another one, what will be there? So it will be there the Py. Py means what is my? Exactly 90 degrees here. 90 degrees we cannot draw here. So this is what is my here? Py. So this is Py. And this is what is my here? Py. So Py and Py, is there any chance of overlap? No. So that's why it is what we will call my here zero overlap. Okay, so this is about the, is there any Py and Pz overlapping? No. This is what is my Z axis. Py, Pz and Pz, Px overlapping also will not easily take place, because both they are, because I am taking here Z orbital, Z axis as the internuclear axis. So that's why I am talking about Px and Py. Px and Py, they are perpendicular to each other. When they are perpendicular to each other, there is no overlapping. So if I take x axis is a internuclear axis, then Py and Pz orbital, both are perpendicular to each other, they will not overlap to each other. Okay, no? So this is about the overlapping. One way of overlapping of atomic orbital takes place, and these are the chances. One is positive overlapping, negative overlapping, and zero overlapping. Zero overlapping means overlapping not takes place. So now these are main points of VPD. I have discussed VPD theory in terms of energy, and in terms of overlapping, orbital overlapping concept. So I put together all, and here these are some main important points of what is my here VPD. Yeah. So what is the VPD theory means? According to this theory, a covalent bond is formed by overlapping of atomic orbital of valence shell of two atoms. I already said covalent bond is formed due to what is my overlapping of orbital. That overlapping orbital should be of filled orbital with a opposite spin of electrons. Clear? So that is only off-filled atomic orbital. Covalent bond is formed due to the overlapping of orbital. Which orbital involved in the overlapping? And these are off-filled atomic orbitals involved in the overlapping process. Clear? During this means, and the resulting bond acquires pair of electrons with what is opposite spin. So I already mentioned here one is orbital, and this is one electron, and another one is with opposite spin, and they combine. They are in what it is one. Right? I have written here electrons in which direction? Opposite direction. That is one pair of electrons with what it is opposite direction. Clear? Next, the atom with off-filled orbital must come close to one another with their axes in a proper direction for overlapping. Clear? No? So they have to means I already mentioned covalent bond is a directional and ionic bond is a non-directional. Clear? No? So this is one reason. Why? Means the atom, the orbital, the off-filled atomic orbital must come close to one another with a proper direction for overlapping. Means it should not come on its own direction. It has to come in a particular direction to overlap. Because previous I already mentioned positive, negative direction. Suppose pz orbital here is there. This is positive and this is negative. Another p orbital should come in this direction. Positive and negative. It should not come in this direction. Negative and positive. Then there is negative overlapping. So and they have to come for the overlapping in a particular direction to form a covalent bond. So that's why covalent bond is a directional. Clear? And as a result of overlapping, there is a maximum electron density between the two atoms. Clear? So when two atoms they overlap, the maximum electron density I already mentioned. This is the region of overlap, and this region of overlap, and we will find the probability of finding electrons are more in this overlap region. Clear? I already mentioned. That is. And greater the overlapping, this is very important. And greater the overlapping and the higher is the strength of the chemical bond. If our extent of overlapping is greater and the bond formed is very strong. Clear? So greater the overlapping and stronger will be the covalent bond formed between the two atoms. Clear? Last one. Electrons which are already paired in valence shell. This is important. Clear? So what they have mentioned, you see, electrons which are already paired in valence shell can enter into the bond formation. I already mentioned here, you see, paired electron can enter into the bond formation. Paired electron will not enter into the bond formation according to the Vpd, only off-filled, because here paired means fully filled. But when it can involve in the bond formation, if they can unpaired first and shift into the vacant orbital of slightly higher energy of the valence. Simple example I will take. I will take here carbon is there. Clear? So carbon is formed here CH4. 4 hydrogen atoms are coming close to the carbon. First of all, carbon has to form how many bonds here? 4 bonds. If you write carbon electronic configuration 1s2, 2s2 and 2p2, you know valences are only involved in the overlapping. So that's why here what it is now. 2 electrons are in the orbital. Clear? So another 2 electrons are present in the what which orbital? P orbital. And how many unpaired electrons are there here? Off-filled atomic orbitals we have 2. This is 2s, this is 2px, and it is 2py. We have 2 off-filled atomic orbitals are there, so it has to form how many bonds? 2 bonds, but it is forming how many bonds? 4 bonds. So that's why. And in this case, what happened? And one of these electron will jump from the 2s orbital to and 2pz orbital. Now all are off-filled only. All are off-filled means it will form the 4 bonds with the 4 hydrogen. These off-filled electrons involved, orbitals involved in the overlapping with the hydrogen and forms the CH4. Means you may ask, how this electron will jump from the 2s orbital to 2pz orbital? Because here the energy difference is very small, and you know I already mentioned, when atoms are coming close to each other to make a bond, then attractive forces first operate. Attractive forces will be present. When attractive forces are present, then what will happen? Due to the attractive forces between the two atoms, some energy will be released, and that energy compensates here, and that energy is used to jump the electron from the 2s orbital to 2pz orbital. You need not to supply any energy here. Clear? So these are main. So now this in this case boron also. Boron what is 5, 1s2, 2s2 and 2p1. Means here valence electrons here how many are there? 2 electrons are there. In the p orbital how many are there? 1. But it will form how many bonds? 3 bonds. Why? Means it is a ground state. In the excited state, Clear? What will happen? One of these electron will jump into the p orbital. Clear? So what will happen here? 3 unpaired electrons, off-field electrons are there, they are bond in the bond formation. That is only. The electrons which are already paired in the valence shell can enter into the bond formation if they can unpaired first and shifted into the vacant orbital. First they are shifted into the vacant orbital, then only these will involved in the overlapping and to formation of the bond. So these are about what is the main points of Vpd. So next heading is types of overlapping and nature of covalent bond. Clear now? So the covalent bond is classified into 2 types based upon the overlapping, type of overlapping. Clear now? And based upon the type of overlapping, and covalent bond is classified into 2 types. Clear now? What is the first one is? The first one is sigma bond. This is symbol, what it is here? Sigma bond. And the second one is here pi bond. Simply we will write here pi bond. Pi means here symbol of this is pi. Pi bond. Clear? First we will discuss about sigma bond, and after that we will go for pi bond. Put the first one is sigma bond. Sigma bond. Clear? And this type of covalent bond is formed by end-to-end or head-on overlapping of bonded orbitals. Bonded orbitals along the internuclear axis. Along the what is here? Internuclear axis. And this can also be called as head-on overlapping or axial overlapping. And this sigma bond can be formed in 3 ways, and how that one we will discuss. Clear? Write the first one here. This type of covalent bond is formed by this type of covalent bond or sigma bond. Directly you can write sigma bond is formed by this type of covalent bond is formed by end-to-end, formed by end-to-end, or what we can write here, add-on overlap of bonding orbitals. Overlap of bonding orbitals. Along the what is here? Bonding orbitals along internuclear axis. Internuclear what it is here? Internuclear axis. And this is called as head-on overlapping. Clear? Head-on overlap or head-on overlap or axial overlap. Head-on overlap or what it is here? Axial overlap. Axial what is here? Axial overlap. Axial overlap. Clear? So this can be formed by means 3 combinations. This is about the what is sigma bond. Simple it is. This type of covalent bond, this sigma bond is formed by end-to-end or head-on overlap. What is that one we will discuss? Head-on overlap and of the bonding orbitals, atomic orbital, bonding atomic orbitals along the what is internuclear axis. Along that overlap should be taken place along the internuclear axis. Which one is taken as internuclear axis here? Z axis. Clear? And this is also can be called as head-on overlap or what is axial overlap. And this sigma bond is, and it is can be formed a combination of following overlapping. The first one, 3 overlapping. The first one is SS overlapping, and another one is SP overlapping, and the third one is PP overlapping. Clear? So first one is SS overlapping. Clear? Put the heading. First one is SS. How this sigma bond form? Means in the 3 ways. SS overlap or SS overlapping. Clear? So how it will be formed? Overlap of two s orbital, two of field s orbital along the what is nuclear axis, internuclear axis, and forms which bond here sigma bond. Clear? So write that one. So what we have to write here? Write single point in this there overlap of two of field s orbital. Just write here. Overlap of two half field, because overlap means half field must be overlap of two of field. Which orbital here? S orbital, two of field. S orbital. Clear? Orbitals. S orbitals. Along which one? Along internuclear axis. Internuclear axis. Internuclear axis. Clear? So what is that one? See here, this is one s orbital and another one is this is one s orbital. Clear? S orbital and s orbital have just assume here one electron is there, one electron is there. So then what will happen? Overlapping, and this is overlapping. SS is overlapping. Clear? Then which bond will be formed here? There is a sigma bond will be formed. This is one type. Clear? So this is s orbital. Simply I will write s orbital. This is s orbital. Clear? So you will get what it is? S overlapping. This is just simply write s orbital, and this is what it is? S orbital. This is what it is? S overlapping. This is SS overlapping. This is in this case one sigma bond will form. Another one, how the sigma bond will be formed here? SP overlapping. SP overlapping. So how this SP overlapping will be formed? Clear? So you know that, and overlap of one of field s orbital with the another of field of P orbital of another. Clear? Right here. Overlap of, and here overlap of one half field overlap between one of field, or simply overlap of one of field s orbital with one of field P orbitals of another atom. Clear? So that is what it is SP overlapping. Suppose if I write here, this is what it is Z axis, internuclear axis. Clear? So now this is what it is here. S orbital. This is what is which orbital? S orbital. Then I will take here P orbital. P orbital means which orbital I can take here? I can take PZ orbital, because S orbital and which orbital will be formed along the x-axis means which orbital I have to take? PZ orbital. Then what will form here? You will get the clear? So here S and PZ overlapping. S and PZ what is here? Overlapping. This is here also which bond will be formed? One sigma bond will be formed. And last one is here. The last one. Clear? So what is the last one? PP overlapping. In the PP overlapping also overlapping. Which bond will be formed? And bond formed is sigma bond. PP overlapping. Clear? So in this one what it is? Overlap of two simple. This is overlap of two half filled. What is here? P orbital along what is here? Along internuclear axis. So that is one is this is PZ orbital, because along the axis means what? PZ orbital, and another one I will take what it is. This is another PZ orbital along the nucleus. Clear? So this is Z and Z. Then what the overlapping? This is overlapping. So which overlapping here? Z, along with the Z axis. So here this one, this is PP overlapping. This is PP overlapping. Clear? No? So here also which one will be formed? Sigma bond. And here also which bond will be formed? Sigma bond. And here also which bond will be formed? Sigma bond. Clear? No? So this is about the what is no sigma bond. See, sigma bond can be formed in following ways. SS overlapping along which one? Internuclear axis. SP overlapping also along the internuclear axis. Around the internuclear axis two takes place overlapping. One should be the S orbital, another should be which orbital? Z orbital. You should not take P orbital. This is which one? This is Z axis. Internuclear axis is a Z axis. Clear? No? So next one is PP overlapping. Here also overlap of two off-field orbital along the internuclear axis. One is PZ and another is PZ, and you will get PZ overlapping. Here also which bond will be formed? Sigma bond. And next we will discuss about the Phi bond. So next one is Phi bond. Sigma bond we have completed. Phi bond. This Phi bond is formed by lateral or sideway overlapping of p orbitals. Clear here? So what is the sideway or you can lateral overlapping that I will discuss. Clear? So means this overlap of orbital, it must be done at right angle to the internuclear axis. The overlap should be right angle to the overlapping of p orbitals or p atomic orbitals, right angle to the what it is here? Internuclear axis, and that overlapping we will call the sideway or lateral overlapping. And due to that overlapping, which bond will be formed here? Phi bond. Simple. I will take one example here, and p orbital, px orbital I will take. This is which orbital? Px orbital. And another px orbital. This is px orbital. Clear? So now take two overlap, atomic orbital overlap each other. You know, this is internuclear axis. I have mentioned already. Z axis as considered as the internuclear axis. Now overlapping will take place. This is overlapping. Clear? So overlapping means how it will be? This is. Clear? This is overlapping. See, this overlapping is right angle to the which one? Nuclear axis, and that we will call as a lateral overlapping, or what we can call sideway overlapping. This is sideway overlapping. Previous what is this is head-on overlapping. This is means end-to-end overlapping. That we will call as a, the bond form we will call as a sigma bond. But here what it is? The bond formed due to the sideway overlapping or lateral overlapping is called as a, what it is here? Phi bond. So in this phi bond, the electron density, if you see, electron density is placed above and below the internuclear axis. Clear? So you know that these are nodes. Nodes means what is the probability of finding electron will be 0. Means here at this point electron density will be 0. So that's why, and due to this overlapping, electron density will be, clear, above and below the what it is here, internuclear axis. Clear? Or sometimes this can be represented in this way also. So this is P, one is Px and another one is Px. We can represent and this Phi bond like this also. Clear? Here the bond formed we will call it as a Phi bond. Okay? And remaining we will discuss in the next.